La presentación muestreo de nieve para microplásticos y nanoplásticos, análisis en Punta Arenas y en latitudes medias en el hemisferio sur. Adelante, por favor, doctor Barja.
¿Pueden ver mi presentación?
Station now?
¿Se ve, Francis?
Te vemos a ti todavía.
¿Ves mi presentación o no?
No. La vimos y después se salió.
Voy a desconectarme. Voy a volverme a conectar. ¿Sí? Hola, buenas tardes. Disculpen los inconvenientes. Sorry for all of these issues with the transmission. My name is Boris Barja. I work in the University of Magallanes. And thanks to the organizer to invite to me to give this this talk. I will talk in Spanish. I think it's better. It's okay, Francisco?
Sí, perfecto.
Okay. Nuestro trabajo se nombra
So, our work is named snow sampling for micro and nanoplastics, and its analysis in Punta Arenas, which is a place in a mid-latitude site in the southern hemisphere. And as I told you, my name is Boris Barja. I worked at the University of Magallanes at the Atmospheric Research Lab. And this work, we've been doing it together with the researcher, Maria Godoy, who is in person right now in Valparaiso, and my colleague Kajan from the Columbia University in the United States. This is a little bit the topics that we'll cover. About our laboratory and measurement site and aerosol results. I'll also talk about the procedure for snow sampling and some things about the future. Our measurement site is located in the Magallanes region in Punta Arenas at that latitude and longitude shown 53 degrees south and 77 degrees west in longitude. And our location is a privileged location for atmospheric measurement down here in Magallanes region, because as it is shown on the image on the slide, we are between latitudes of 45 and 60 degrees south, where we have dominant winds from the west and coming from the Pacific Ocean, and we have very clean and pristine conditions and clean conditions for aerosol measurement. And since we have a low concentration of aerosols, this allows us to have a baseline to conduct studies related to this. Likewise, the closest land or country that we have to this one is New Zealand, which is 7 degrees north and 7 degrees to the north and 8,000 kilometers of distance to the west. So this is Punta Arenas like. This is the Brunswick Peninsula, where you can see the city of Punta Arenas, and in yellow is the measurement platform, the location of the measurement platform where our lab is located, which is on the shores to the Magellan Strait. And to the west, in red dot, or in the red arrow, it's located at the Mirador Hill, where we are right now. This Mirador Hill, we call it in Spanish Cerro Mirador, like overview hill. It has an English name, Fenton, but it's better known as in Spanish. So this site is located 10 kilometers west from the city and 600 meters above sea level. Here you can see some data of the city. It's the highest point to the city, and you can see some images how this hill is snowed. It snowed during winter time, in the winter season, and sometimes in summertime snow disappears. There on this side we installed an observatory called Fenton Atmospheric Observatory, where we started having measurements on site of aerosols, and this was established through a collaboration with the University of Magallanes and the Tropos Institute of Atmospheric Research from Germany, and collaboration with the 4th Brigade of the Air Force here in Magallanes. Later on, this agreement was expanded with collaborations with France and Dr. Francisco Cereceda, and also with the Chilean Antarctic Institute, with the project of conducting measurements, and also the University of Talca, with collaboration, and we initiated measurements on the site back in 2019, and now it's been 5 years now since the establishment of this measurement site, and we want it to remain over time, to be able to extend measurements there. Some instrumentation is shown here. This instrumentation is with collaboration with the Tropos Institute, with whom we have an SMS, PC, and a CMC to measure particle size distribution of aerosols in the atmosphere, from size of nanoparticle size up to microparticles, and also to measure distribution of particle size that are on the atmosphere that can act as condensation nuclei. Also, we have sampling of aerosols in filters to make chemical analysis, and also studies of ice nuclear particles. Likewise, we have a sensor to measure the snow depth that we have here, which is accumulating there, and also a rain meter to measure liquid and solid precipitation. We also take samples of precipitation, the total precipitation of aerosols, either rain and precipitation, and also aerosol by gravity. And also we have a weather station to have the weather variables and monitor these variables. Now I'll show you specific results about ice that was published in collaboration with the colleagues from the University of Tropos, the Institute of Tropos. Here I'm showing you a graph where you can see the particle amounts that form ice crystals. Down below is the axis for temperature, and vertically you find the amount of ice. And also this graph is very much like the one shown by another colleague, the colleague that spoke in the morning from Japan, the one that he showed. So we obtained those results in our measurements, and as you can see, it shows very similar behavior to what this colleague of ours showed. And in our report, it is found in an intermediate term for reports done in a forest environment in the United States, for example, in a publication back in 2013. Also, if we compare this with measurements done in the Southern Ocean, our measurements are set in a medium amount of particles that we find in our measurement sites, the amount of particles that are capable of forming ice crystals in our measurement sites. It's in an intermediate point between the behavior that they have in a forest environment and the behavior that they have in the Southern Ocean and close to Australia. A similar procedure was done that was shown by our colleague, where our samples were heated in order to determine how many particles of this type have a biological component. And we could see that by heating them up, the amount of particles that the ice crystals formed, this decreased. And by making a relationship between the amount of particles that was identified as heat resistant, which is in red color on the graph, there was a relationship which we call it biological particles. And on the graph below, you can see that 90% of particles of the ice forming particles for higher temperatures, at least 10 degrees Celsius, were particles of biogenic origin, proteinaceous, with values for temperature lower than 10 degrees Celsius. You can find 70% of these particles behaving that way, which gives us a biological origin. Therefore, we can conclude that there is an important contribution of biogenic particles, or another type of particles, which are not the mineral particles coming from the cortex, from the earth cortex. So, why did we decide to study microplastics? As our colleague Francisco presented, there are certain publications which we can highlight here. For example, in 2019, they reported about microplastics in the snow from the Alps down to the Arctic, or up to the Arctic, and the effect that they may have. And then other publications started to appear where there was an influence or an influential factor of microplastics in the snow in other regions in the world, in China, Japan, as well as in Spain, as our colleague Francisco showed. And finally, last year or a couple of years ago, we had the first evidence of microplastic in Antarctic snow, and there's no report in our region about microplastic here. As we have talked about, this microplastic can be transported in the streams, in the atmospheric currents. Together with this, there's also another publication about the influence that microplastics can have in the formation of clouds, as our colleague from Japan showed us. Therefore, these are the two motivations to try to measure microplastic here, or detect it. And here started the collaboration between the researchers from the University of Magallanes and Dr. Richard from the University of Columbia. He conducted a visit to our university, and out of that came up the possibility of a collaboration in early this year. And by late this year, and we decided to collect snow samples during our winter season, during the months of June up to October. And the main thing was that we needed to prevent or minimize pollution during the sampling. And for this purpose, we needed to choose the container to put our snow samples. And it should be plastic, therefore it had to be glass or metal. And then we chose these glass cans, which have a metal lid, and that metal lid doesn't have plastic either. These containers, these jars, were preheated, burned in a stove, as well as all the utensils, as is shown on the image. They were heated up to 500 degrees Celsius for at least 6 hours in order to eliminate all the possible contamination that these jars and lids and utensils may have. Likewise, they were heated up foil, the aluminum foil, was heated up in order to use it later to wrap or cover these jars and lids, and they were completely covered with aluminum, and these jars were capped, and as you can see, they were covered completely with this aluminum foil previously heated. Then the snow sampling took place during snow events, when it was snowing. Therefore, so we sampled snowing events, and for this we left 2 snow jars in the snow so that they could get filled with the falling snow, and thus we had a jar for the sample and another jar, the white one, where all the background and manipulation may happen, and also the whole trip that the snow sample can have. And on these jars with snow to the left, as you can see on the image, they were capped and also numbered and stored in a temperature below 20 degrees Celsius. All in all, 6 samples were taken during our 2024 winter time. And this snow will be sent. That's the next step. These samples of snow will be sent for their analysis at the observatory of the University of Columbia. And the methods or procedures that we will use, as you can see here, is a branch advanced microscopy to have an image of these micro or nanoparticles of plastic. This was published, this report was published and this method was employed to determine the amounts of microplastics and nanoplastics that the bottles of water contain, the ones that we consume. And it was determined that the detected polymers and different plastic types detected in that consumption water, drinking water, and the same method will be used to make plastic particle analysis from the snow samples. So in the future, we need to improve this snow sampling for the next winter season. And also we're thinking about maybe sampling liquid precipitation with an improved method, very much like snow. And we're also thinking about sampling aerosols from the air through other methods, such as filter placement, which is something that we have planned for the future. And so also to increase the collaboration and create networks. Maybe before this or after this event, we can keep doing this in collaboration with our professor and our other colleagues present. So far, thank you very much. We wanted to present this small effort, which is the beginning of our microplastic research, showing what we've done so far during this winter time. Thanks to the organizers, thank you very much, and also to Professor Tanaka for inviting me to give you this presentation. Thank you very much, and thanks to Francisco as well and his team and collaborators for inviting me to participate today.
Ok, bueno, muchas gracias, doctor Barja. Lo invitamos a quedarse online ahí porque vamos a tener luego una sesión de preguntas, por si hay preguntas para usted. Y bienvenido también a escuchar la próxima charla.
Sí, muchas gracias por estar. Si acaso hay algún problema con
If there's any connection problem,
Técnica,
we
está presente, puede quizás contestar algunas de las preguntas sobre
Ok.
la presentación.
Perfecto, muchas gracias, doctor Barja.
Gracias por y
Bueno,
contacto aquí.
ahora siguiendo con nuestra última presentación, antes de continuar con el bloque de preguntas y respuestas, damos bienvenida a el doctor Rubén Araya de la Universidad de Antofagasta.
Ruben Araya from the
Exposición
University of
acerca de
Antofagasta with
aerosoles y
the
meteorología.
presentation about aerosols and meteorology in the northern region of Antofagasta in Chile.
Well, good afternoon. I don't know if you can hear me well. Before all, I would like to thank you. Thanks Universidad Federico Santa Maria through Francisco for the invitation. The colleague and friend, Dr. Maruyama, and all the people here. Well, some months ago, Dr. Maruyama asked me to participate in this in this symposium regarding this topic, which is aerosol and meteorological observations in the Antofagasta region. And even if it's far from my area of comfort, because my comfort zone, because I work in something different. The last year I have participated in Temuco, and there are some other collaborations. And well, I am the dean of the science of the sea, and I'm trying to be the next to some collaborators can contribute, and also that I would like to be involved too. Well, we were in Punta Arenas, now we're going to the north in Antofagasta, 1,400 kilometers to the north, absolutely different conditions, from the snow to the driest desert in the world. As you can see here, is the question that emerged here is that why the desert of Atacama, why arises this environment of the driest environment of the world is particularly due to different conditions that, as the colleague of IFOP said, there are mechanisms like the interactions, ocean and atmosphere. And in Chile, we have, particularly in the north of Chile, we've got these characteristics due to, as you can see here. Here is Antofagasta, where's the red spot. On purpose, we are in the 23-degree latitude south, and we are the widest region of Chile. How many kilometers from your station? 120. Imagine which is the width of Antofagasta region. So what we have here is there are some winds going to the north, and also a Humboldt current. I don't know if you can appreciate that here, that carry cold waters, and these cold waters and the geographical accidents that exist generate that profound waters can emerge to the surface, and those are waters, very cold waters with a lot of nutrients. And we've got also the conditions that would be called the anticyclone of the Pacific that generates masses of cold water. So if we add up the Andes mountain chain and Cordillera de la Costa mountain chains at the edge of the coast, with a very high mountain chain from 4,000 to 5,000, it would generate that the humid fronts coming from Bolivia, from the Atlantic to the west, cannot pass the mountain chains, so there is a space where this humidity does not penetrate, and that's why it generates those conditions of aridity. And Humboldt current with a lot of nutrients, they generate the abundance of fishing resources that our country has and also the south of Peru. So here you can see latitudinal sea of the topography of the region of Antofagasta, and basically I took that from the article from Arenas and Associates. They make the cycle of the aerosol and environmental flows. Here we have an area which is related to the coastal zone. We've got the Humboldt current, and we have the coastal mountain chains that is very high too, around 1,000 meters. It's very particular, that doesn't exist in other places. So there's a phenomenon called Camanchaca from 18 degrees latitude south, Arica, up to 30 degrees south, which is here by Valparaiso. And it will generate that they will generate this kind of clouds that they are particular because they can generate thermal inversions. And the next slide we will deal with it. So if we look in that slide, we will have this circulation that will penetrate this humidity and this Camanchaca over the coast mountain chain, and then we've got the Central Valley, and then mountain chain of the Meco, and then the semi-arid zone, which is the depression pre-Andean, and then the Altiplanus. And then that is the Puna, and up to the coast we've got the Atacama Desert. This will mean the high mountains and in the margin of the coast, that some processes where eventually we will see some results published by other authors, that there is a retention, and maybe these just stay in this zone and does not get transported to the pre-Andean depression towards the other side of the mountain. So to mention it like this, Antofagasta is crossed by the Capricorn tropic and 23 degrees latitude, but from Antofagasta to Argentina, this is a travel of more than 400 kilometers or more than 500 kilometers. In that line and latitude line, you will find with this transition where you will get the Andes and you will cross the Andes, and you will find the tropical zone. A lot of trees, a lot of humidity, a lot of butterflies, and those are the conditions that we have here particularly. They are not only negative conditions that because geologically the north allows us to have some mineral wealth. If we see in the coastal part from Schultz and et al., and this margin, this coastal range with the Loma Belt, this generates a thermal inversion layer that generates these kinds of stratocumulus clouds that generate subsidence, and they can go up and go onshore, and it generates some conditions of humidity that allows the life in this area, which is very different from the desert area. In terms of meteorological observation, I wanted to show this image that I have taken from the thesis of the University of Concepción, Tomás Guzmán Muñoz, that presents the total annual precipitation in Antofagasta between 1970 to 2004, the histogram in relation, it's the blue bars in relation to the occurrence of, I don't know if it's blue or not, but the continuous line represent the occurrence of the annual average of the sea surface anomaly, and the red spots, the occurrence of the El Niño events. We're going to call it the Niño or Niña. So we can observe that there were periods that we have a high concentration of precipitations around 1975, 76, a lot of precipitations, but for instance 1991 with higher precipitations too, and it coincides with the phenomenon, dense phenomenon. So there were some particular conditions to have a lot of rain. I was very young in those years. I am from Rancagua, in the central south of Chile, and I was very familiarized with the rain. I was in the third year of university, and I started feel the rain, and so I took the clothing that was outside and keep the clothing inside. And all the city, the other day, all the city was destroyed because this rain provoked the flooding and scrambling from the hills. So all the city was destroyed. Maybe Francisco remembers that. So what is interesting here, that those phenomena are related only not only with Niño and Niña. Those are very important, but they are very important. They govern those processes, and they are important in the aerosols and also microplastics. So that's the interesting thing. I didn't have any idea of microplastics. I don't have any idea of microplastic, but since I am the last one and I've seen all the presentations, well, I say it's, oh God, it's complex, it's difficult, it's a challenge, a very important challenge for next year. And since I work in avalones and we are interested in a circular process, and I will deal with my cultivation of avalones cannot be contributing with the footprint of microplastic wells. How the global conditions can provoke heavy rains, and this is what happened, the perfect storm that happened in Antofagasta in those years, to generate those phenomena with consequences that were fatal for a lot of people in Antofagasta. This was taken from Vargas and all in 2000, where you can see here, in the case of the anticyclone of the Pacific, this anticyclone is downstairs when there is the Niña, and the subtropical convergence is outside. And so what happened, we were in a Niño phenomenon, the diminishing of the winds. From the equator there were hot waters, from more evaporation, and all this happened in Antofagasta. So to occur what unfortunately occurred. So I'm going to show you a picture. The precipitations you can see again. Also, this coincide with this abnormality that with the index of temperature with the surface of the ocean, they coincide. And for instance, you can see when it was the high incidence, and it coincide with the high incidence of the phenomenon of the Niño, the high temperature of the sea, and at the same time the normality of the surface of the sea. So that was what's generated in this situation. Nevertheless, during time from 1905 to 1995, it's not only the same things. There are periods that have occurred and some periods that's not occurred, but the Niño phenomenon is provoking this, and we have to take care with the emergency issues. So even though we are discussing scientific results, we are getting to know it is important for the decision taking of public policies. So how this is going to arrive to society and how this is going to be translated into important policies. Here you can see images of the city of Antofagasta the day I woke up and I found this. Look up the devastation. Due to this, or due to Vargas, which now is Gabriel Easton, that is the geologist that is he's the one in charge of the San Ramon failure. So he was studying geology. He tried, and so he's going too fast. So can please somebody tell him to go a little bit slower so I can follow him, because otherwise I cannot. Here another image of 2023. Here's a balance of the aerosols of the general reported for the planet. So where you can hear in the north of Chile and Antofagasta here as a hyper-arid region, and also now you can find new techniques as just and people who's working in some well, there are some approximations, methodological approximations to make data. There is people working with tree. There are something taken as witness. Also, there's the methodology of the witness in the basin of the sea and sediments of the sea, and also in environments. Dr. Cereceda said that he's interested in take witness in the mountain chains, so to understand how phenomena are occurring in the Universidad of Antofagasta, where we have a colleague. He's a lot of experience. And in the basin of the desert, he is taking some samples of sediment, and where he can identify how the rate of sedimentation, how many years, and how deep was this, and what happened. He could rebuild, and he could have determine the natural conditions and with anthropic conditions, and not only those samples. Well, I know that he's got a lot of samples from the decades of the 90s, and there are other new investigators that have incorporated, and we've got Dr. Alexis Castillo. He's now an investigator in the Universidad Católica of the Maule. He's showing some bays of taking samples in some bays in the coast that he could allow to know. I don't know if those microplastics could be registered and could be there present in those sediment witness or sediment samples. Francisco, for instance, or the colleagues, whatever they are, maybe to take contact with Jorge and see those witness, and maybe those are preserved, and maybe they can indicate phenomena associated to the anthropogenic activities. So they started 80 years ago Now they are in the snow, in the ice. They're going to show it in this lagoon in the mountains. So it's a very interesting tool to correlate that with some global phenomena that are occurring. In this sense, particularly in the north, we have an influence in the Niño and Niña period, and they will generate some patterns that will to understand those processes. So we are talking about some there are conditions to generate those rains, and also in the north of Chile there's a mining activity. We are a worldwide mining capital as a region. I don't have any connection with the mining, but the region is, and we've got a series of mining places connected with Antofagasta. For the Japanese colleagues, is one of the biggest city of the big north of our country, is in the coast and is far from other urban centers like Iquique. Iquique is 400 kilometers up to the north, and then we got Taltal 300 kilometers from Antofagasta, and Calama to the east 200 kilometers. So those are risks that somehow they can provoke, apart from floodings, crumblings, they can provoke pollution of the environment.
Here there is a work of Saneta with the collaborator Jorge Valdez, where they wanted in the black dots up here, I don't know if you can see those black dots, they're sampling stations where they collected the first sediment layer and they analyzed those sediments in terms of metals. And also they established how they disperse themselves, the particles minor to 75 micros, how they disperse by effect of the wind. The wind originating in this area of the Atacama Desert, mainly due to the difference of convection between the temperatures at night and temperatures during the day. And likewise, you can see in these on these purple spots, purple, rosy, more pink, where indigenous communities are located. And here, the Calumet city is located. This is the center, the communities. There was a mining site, an open pit mining site, the biggest one in the world, Chuquicamata. Now Chuquicamata, I don't know if you know about it, but Chuquicamata disappeared because the copper price was so good that the production required to destroy Chuquicamata in order to keep processing that material and keep extracting copper. And here where Calama is located, there are rivers. We have the lower river that goes through the Calama city, and this its source is up in the mountains. Unfortunately, won't be tomorrow, but a colleague of mine will present microplastics in the lower river. And it seems to me very good because I was reviewing and there's no information about microplastics. Very little of the north of Chile, and there was nothing about lower river. So fortunately, a colleague of mine is approaching this, is covering this. So if he needs any help of using a lab in Antofagasta, doors are open for him to take samples as well. And so, generally speaking, this is very important. But because here you can see on the yellow dots or circles, mining operations, all the mining operations that we have. All of these are big mining operations. So it's not a minor thing, the effects that this might bring over the population, because this generates aerosol dust and metal alloys are transmitted and conveyed, and ultimately they can bring problems. On this image here, you can see how the space distribution of copper, molybdenum, and lead and zinc on the high-low basin this symbol here stands for the mining sites, and you can see mining sites in the reddish or redder color. It shows more concentration of micrograms by kilogram of these metal alloys, and you can see that in the case of Calama, you can see that we have high concentrations of these metal alloys in the midst of the city, and at the same time, as you move away from here, the effect goes down, and this could be related to the wind and also the movement of sterile material that are moved around by trucks, and the wind transports this as well. So this is very important. Why? Because there's no legislation protecting these communities. So we're talking about sacrifice areas, but the sacrifice area cannot be immersed in regards to what the population is. Now, in terms of accidents or accountability, industrial accountability, if you will, we have one of the biggest examples in the planet, which has to do with tailored droppings in the city of General because of the mining activity. I don't know if you've traveled ever to the northern of Chile. If you've gone through General, there's a huge beach, and former President Lagos was sort of like swimming on the shores of the coast. But all those sand beaches, they are mining tailings, mining tailings that were deposited on that area for years. So it's important that academia can contribute with an article like this that points out and discusses how these results should be used in order to create some environmental standards and legislation to protect citizens. The same happens with the spatial distribution of arsenic, calcium, sulfur, strontium, lithium, etc. Here you can see that in the case of arsenic, the highest concentration of arsenic, even though there is an arsenic background, because the north is geologically mining or mineral, this has increased because of these mining extractive processes. So there is studies that point out that ancestral communities of this region have certain characteristics that allows them to absorb and not have secondary effects because of the high levels of arsenic. Another evidence, this is also of the Jorge Valdez group, a colleague of mine that works in Brazil right now, in the Incacoya Lagoon, located 40 kilometers away from Calama. Now in this pond or lagoon, Jorge and his collaborator took sediment witnesses and analyzed the wind effects, how sedimentation or precipitation of these aerosols or environmental dust might be influencing mining in terms of what there is of sediments in this pond, and at the same time they could detect that the increase in the concentration of certain minerals might be associated with the increase of the production of copper. For example, here you can see how this has been going up over time since 1990 up to 2010 in the production of copper, but also the counting of copper in the pond of Incacoya also increased, and this goes along with the witness of Illimani ice. Therefore, there is a direct influence from the mining activity that generates certain suspended dust that might be depositing on these lake systems. And when you match this with certain parameters, such as the decadal oscillation of the Pacific. This coincides with the precipitation and increase of sedimentation, for example, of sand and other materials. You can see on the decadal oscillation of the Pacific, when above zero means that the Nino phenomenon is predominant, and when it's below zero, the La Nina is predominant. When the El Nino is more predominant, the winds go down, and when it's the La Nina, then the winds go up. So this is interesting in terms of the dispersion phenomenon of aerosols in the north of Chile are very important, but at the same time, they haven't been considered in more complete studies in order to determine what's going on. Now, another study of I and collaborators, what did they do in a general term? They placed different sediment traps from tramp T1 at the sea level, so to speak, here very close to Antofagasta, and up to trap number 10, which is on the Andes mountains. And they assessed how the patterns, the precipitation patterns were of different substrates or soluble salts or insoluble salts. What did they prove? That in the case of the sediment traps more located to the coast of the Antofagasta region, certain soluble salts dominated, mainly because of the splash origin, the wave splash, and also microorganisms, unlike the dust trap number 10, located at the Andes mountains, where they could see that there was more depositation of substrates of insoluble dust at higher levels, where nature of the substrates being deposited were more related to, for example, the origin of the salars and so on. This is important too, because now this lithium extraction will start, and we'll be adding other types of phenomena. And salars are located geographically in different sites regarding what the mining deposits are. And this is logically a point of attention that we need to keep approaching. And now in terms of plastics or microplastics or macroplastics, in my search I only came across with 3 articles related with plastics in the region of Antofagasta, and almost all of them are related to what in the fjords is done. And also in the Mapocho River, there's also another microplastic study done, and also in the region of Antofagasta, very little. Some colleagues in our faculty with students, pre-grade students of marine biology, they studied the birds in the Bay of Mejillones. They were using plastic to build their nests. And in fact, they detected that in 2 ports, GNL and X, they were building their nests with plastic that they pick up from the environment. And those plastics come from mainly the mining industry. Now, about the percentage of these plastics. They're mostly composed of X and GNL. Here you can see on each one. For example, wires, 44% plastic bags, solids, solid plastics, fishing ropes, fishing lines, fishing nets, fishing fibers. Why? Because fishing activity in Mejillones is high, but here you can see how they change from one to another. Now, in terms of colors that they can choose from, in terms of these plastics, mainly these nests are built with plastic, transparent plastics, such as in the case of X, 66% and GNL 73%. This, however, brings consequences. What will happen when those plastics are incorporated in the trophic network of these birds, and finally they move on to the mammals that can consume them? So those are consequences that we need to study. Another study that I found, but I don't put it here, is another colleague, a researcher at the Faculty of Sciences of the Sea, studying construction plastics. When you put together two concrete blocks, they must be separated, and they have a dilatation. So they place something like material, soft material, plumavit is called, and on the Antofagasta coast, this is very much used, and it's important to know that this plastic might be ending up in the sea. And another article that I found with Amenabra and collaborators that came up in 2024, people in Coquimbo, where they assess microplastics coming into the Humboldt currents, and they derived somewhere else too. Apart from the problem itself, we don't know yet what happens with these microplastics, how they release certain compounds, how they can affect the reproductive cycle of invertebrates in the sea, and this is of vital importance. With these images and reflections that I want to show you, it's important to establish and show you too that we probably should collaborate with each other. Dr. Jorge Valdez just wrote to me and told me that he will get in touch with Francisco to establish certain collaborations, and also with the Japanese colleagues, because we have certain similarities, very interesting similarities that might harbor interesting scientific questions that we need to address. Thank you very much. That will be my presentation.
Ok. Ok. Bueno, supongo nos quedamos hasta que las velas no ardan o priorizamos preguntas. ¿Qué dice el público? Ya. ¿Cómo? Sí, no, correcto. Ya, oye, tratemos de organizar mejor por una pregunta por cada panelista en los bloques según el orden, ¿ya? Así que, profesor Cerecea, si hay un micrófono por ahí, voy a llevar el mío. Preguntas. María Angélica, si te puedes acercar, por favor.
Hola, tenía una pregunta para Francisco, que tú hablaste de esta medición de black carbon continua ahora, ¿cierto? ¿Lo has comparado con la medición discreta que hacías antes y que colectaban las muestras y se ha comparado los resultados? ¿O cómo ves tú ya si tienes resultados de estas muestras continuas? Entonces, ¿qué esperas respecto a las mediciones discretas?
Perfecto, gracias. La verdad es que los NUNATAC tienen mediciones continuas de black carbon prácticamente desde su inicio, de contaminantes, en este caso black carbon en el aire, ¿ya? En concentraciones en nanogramos por metro cúbico. Y en paralelo, nosotros tomamos permanentemente...
We permanently take the carbon measured in the snow. Those are discontinuous measurements. There's no appliance that we can buy or in developing of the black carbon continue in the snow. So we got the continuous measuring, and in this year we publish the first article of the last 5 years of continuous monitoring of black carbon in Portillo, particularly in the non-attack one, we're going to go on Thursday that show the cycles associated to a condition, a typical condition of vehicular traffic. There is a highway that connects the frontier of Chile and Argentina, and more than 2,000 vehicles transit there. So the black carbon has a very characteristic cycle in behavior associated to the vehicle traffic, and also associated to the operation cycle, a summer cycle and winter cycle operation, which is restricted just from 8 to 8, and also the summer, during the summer is the 24 hours. So we can appreciate clearly the differences from one cycle to another. And we got the samples that we take monthly snow measures and no samples, and we measure it, we filter it, a procedure similar to the microplastic, and it's measured into an optical system as well that measures the attenuation and allows to measure the concentrations of the carbon. And in parallel, we are developing two things. First, the model of positional of black carbon, which is we're developing in a Fondesit project. We've got some students, for instance, Benjamin Gallardo, which is implied in his thesis work, and also a postdoctorate contributor. And in the development of the model of black carbon and atmospheric black carbon, we would like to interpret the concentration of black carbon in the snow and in the air. Because of the origin, the atmospheric deposition, with some other colleagues in the electronic and informatic and design area and engineering area, we are developing optic device, multispectral device that will allow, if everything goes well in what we are developing, first equipment developing that allows to monitor in an automatic way and in real time in the snow, in the interpretation of optical images in the snow. So that's what our intention, to evaluate in a better way the concentration of black carbon in the snow, and probably, if it goes well, if it maybe we will be able to do similar things in microplastics or nanoparticles in microplastics in the snow, because they are colorful, and these cameras take big infrared, and they take good pictures with that combination of cameras. We can take pictures from the snow, and if the particles are big enough, maybe we can take pictures and have it. And we are now. Thanks for the question. Any other question for our first lecturer? Don't be shy. In the case of plum, fuel are plum free. So when you plomo, ¿cómo se dice plomo? Plomo, ¿cómo se dice plomo?
Lead.
Yeah. In the case of lead, how, if you take a sample from the snow, how would you, if you take a sample from the snow, it's a good question, because in Chile we haven't done this. We've got some sediments witnessed on sediment samples, and we have noticed the stop of the using of lead that was used in gasoline and fuel. In 1998, no more lead was allowed, and Europe 10 years before. So it could have seen this effect, and all the environmental samples witness trees of sediment samples. In Chile we haven't done that. We could have made the sediment witness ice witness or sample, we need a glacier that with no important melting during the summer. For instance, it's the first samples that we took for the paleoclimatic reconstruction and paleochemical with Swiss colleagues were when the lead hills. It's not that we were looking for hill, but the name of the hill was lead. So the Swiss colleagues were reconstructing with different types of trackers or proxy, and this hill named lead. We took some samples with drills, electrical drills that work with photovoltaic panels, not to pollute the samples. The ice samples were not, they didn't work because they melted in the summer, so the upper surface layers, they infiltrate, and so finally it's not useful. It doesn't work because the witness is contaminated with the track elements from the surface. So you cannot say here you've got the isotopes, but there's a way that are altered. So these colleagues made a new campaign in the Mercedario, which is a hill in Argentina, 6,500 meters. They found a glacier that here my colleague could help me maybe because it has a better stability and it worked, and they could make a determination of high isotopes and some elements, classic elements. I don't remember that if in this witness we could start this issue of the lead, but in the case of the snow, the accumulation of the snow is very short, so it has to be ice witness, and in Antarctica it's much better to do that because the thermal stability of the ice is bigger. So in the plateau, Antarctic plateau, because in the coast it's just 6 meters per year. You have 2, 3 meters, and to go to 6 meters, just you would need some air to get there down there. So we will have just 1 year of samples, chronological 1 year of samples. So we need a place like Plateau Antarctica where you can make perforation drillings of 120, 150 meters to take a paleoclimatic study, an important one. And there's no problem there because it snows 30 centimeters per year, so it's possible there.
Ok, muchas gracias. ¿Alguna otra pregunta para el profesor Cereceda? Sí, no, pues vayamos en bloque más ordenado. ¿No? Bueno, muchas gracias. Ahora para el doctor Leonardo Guzmán, sobre su exposición de María Roja. Por favor, no sean tímidos. Francisco, adelante.
Una pregunta. Me parece sumamente importante, lo mencionaste tú también, respecto de
Before, what is the urgencies of waters, of deep waters that transport, what you said. You've seen it from the point of view of the nutrients, of the oceanographic point of view, but from the microplastic point of view, and obviously from other contaminants, pollutants, it's very interesting because obviously those surgencies not only transport nutrients, but they transport all the pollutants or contaminators that could be in those sediments, and if there are microplastic accumulated there, surely those microplastic will reach the surface. What is this about? Well, it's very interesting, the question. Geographically, you have to you have to allocate the process of surgencies, the Pacific Ocean. In the fjords, the surgencies are different, so the circulation processes are different. But I'm going to try to link it with another processes that may be important with the circulation of micro or nanoplastics. The question is interesting when they are blooming from central Chile to the north, in the extreme south up to Chiloé and near Aysén, they are blooming just in some periods in very special years. The surgencies are very slight. It's not like the intensity you have here in the center of in central Chile. So you relate that, or you link that with the fisheries size. But in the fjords, what you have to understand is, since they are estuarine system, huge estuarine system, in the surface the waters are less saline, and because there are a lot of rain, a lot of river contribution of water, and they flow up to the Pacific, and they may be completed for waters that enter in the depth around 350 meters approximately. Since the red tides go with cysts, the cysts come from the Pacific, and if you get cysts from the Pacific that are inert, of course everything can, of course it can occur the same, and nobody has covered this question because it's very interesting, because those processes in the different fjords take different forms and different ways to express, and some of them are very restricted, and the geomorphology of the fjord, for instance, they have sediments or marine, they are different, and the process can be intense, and there's always how the material, the particulate material is moving. There's always that question. I don't know if you're familiarized with the Millennium Institute is doing. They are analyzing the Atacama seabed, and they were showing us a video, and 8,000 meters of depth in the Atacama bay, seabase, a plastic bag, 8,000 meters depth. I'm going to ask him if there's a group that of that samples that if they are analyzing microplastic, that could be interesting. It can be observed the magnitude of the phenomena we are commenting. I have some other questions. I'm curious, and I'm very good at making questions, so that I think this is an interesting topic, because the transportation of these cysts, if they brings surgencies from the point of view of the microplastic, they generate the possibility that the microplastic particles can be transported and accumulated to the sediments towards the surface, and then through the waves in the surface, and then we'll go to the atmosphere phase. So it's very interesting, this circulation through the Pacific or through the fjord in the glaciers, and it leads me to another question that has to do, as I said, used to tell to the students, the tiniest particles have giant roles, and it leads me some structures that are fascinating, the diatomeas. So the diatomeas has a direct link with the glaciers that are nurturing is nurturing diatomeas. So now that is effectively an accelerated performance of this process. It's going to be more nutrients, it's going to produce more blooming, planktonic blooming, or of this red tide?
Of course, this is a hypothesis currently that of all the glaciers that are on the fjord system, the only one advancing is the Pion 11. The others are going backwards or retreating, and we hope that from the glaciers to the marine system, what we have today is models that allows us to estimate the contribution of fresh water accessing the process of fusion associated with them. But those questions are not being considered so far by no group at all. But this is something that we might expect as a group. Diatomeas are more important than flagellates, and the production in the fjords is explained by 15 species of diatomeas, which are responsible for the biomass that is present in the fjords, particularly in spring and summertime. Therefore, in fjords where these processes today are more intense, one should expect a baseline or levels of production that are higher than usually might be there in those sectors. Another consequence of the climate change, by the way. And last question, or anybody else wants to ask a question? So the model, what type of or size of particle are you using on this model to interpret? The particle dispersion? The particle can be a tennis ball or a basketball from 50 microns. In our case, it's particles that are similar to 30 microns, 20 microns, very much like microplastics, particles. The important thing is that the resolution, you can improve it. Now the scales we're working with on the hydrodynamic model is working on a scale of 800 up to 1000 meters, and the ideal thing would be to go down to 200, 300 meters so that we can have a more localized appreciation of the processes taking place there. And I understand there is a consulting company today that has that capability of generating models where they're representing a scale of 200, 300 meters at a very high resolution level. Very good. Any other last question? I have a very simple question. You pointed out the death rate of 170 of people which you said had to do with the behavior. If you know about somebody eating, now what have been the impact and the adaptation of a small fishing base that had an extractive activity? When the red tide is declared, they cannot exercise this activity. Now the region that currently has the highest restrictive level, where you cannot extract or trade or distribute, is the region of Aysén, because they have a higher frequency and recurrent frequency of paralyzing toxin on the mollusks. What happens with the fishing sector in general is that up north, events generate a social economic impact in the short term, where the state's answer has failed. In what sense? In everywhere in the world, when this type of event takes place, the state has a subsidy plan prepared. The state subsides groups, and the subsidy must be identified. They know who they are, where they are, and an estimation of the subsidy volume to be delivered, and for how long. And this hasn't happened in Chile so far. So when they have agreed to provide subsidy, it's because of the social pressure has forced the state and the authority to make up their mind about delivering the subsidy, which was happening in 2016. That particularly with the paralyzing toxin. Other toxins that cause massive fatalities in fish is salmon culture. That is very much complex to handle, but on the other hand, the productive sector that have other mechanisms to protect their investment. For example, insurances. Usually, the loss, as the insurance companies put it, it might be a loss in the face of the fattening process, but it's projected at the end of the process when the fish has 4 or 5 kilos. Therefore, there's an insurance covering that. There is not a loss. There is not a direct complex affectation, but the inverted capital and the probable profit is very much somehow recovered. But on the other hand, there are difficulties associated with the biomass, the dead biomass. When the fish is fresh, it's possible to take it for direction and to turn it into flour. What has happened since 2016 is that the private sector has hired high sea fishing groups to be available to transport fish as quickly as possible to the only plant there is in the region of the lakes. In case that this plant is not capable of receiving all the biomass in the state to reduce it to flour, there's the possibility to take it to the region of Biobío. However, that alternative has an operational difficulty. Reactive groups that protect the environment because they don't like fish dying somewhere else and because of the red tide and being taken there. So there is a constantly position of taking the micro algae, and this is a problem that takes place there. What has happened? The state is not defining physical places where to deposit inland when there is an excess of biomass to be eliminated, and it's not in conditions to turn it into flour. And there is a difficulty because there's a tension between the decision to be adopted by the state and the state that believes that this private sector's accountability or responsibility. And they can only identify sectors and request authorizations pertinent where they could have spaces where they could eliminate biomass in quantities large enough if this has taken a condition where it cannot be reduced to flour, and somehow dispose of it in a safe place because it could cause disorders because of the sulfuric acids that might cause problems with the public health. It is very complex. This is what was done in 2016, something that was exceptional because there was no other alternative, and if my memory serves me correctly, the 13,000 tons of salmon in very bad state that were inverted at 70 miles from the coast. They were dumped, in the island of Chiloé, and that was done so because all the hired ships had GPS and they were monitored by the National Fishing and Aquaculture Service, which are the responsible parties to conduct the process together with the Maritime Authority. We don't have any responsibility and we cannot take any decisions. We can suggest and recommend, but that's how far our role as an institute goes. Thank you very much.
Bien, ahora nuestro tercer panelista es Boris Barja, pero está la María Angélica acá, si Godoy, si es que alguien tiene alguna pregunta, ya, repito, digamos, cerca del muestreo de nieve y microplásticos en la ciudad de Punta Arenas como sitio de observación en latitudes medias. Don Francisco, le doy la palabra al tiro, ¿no? Va a preguntar, me imagino.
Sí, gracias. Sí, yo tengo una pregunta. Angélica, respecto de un poco técnicas ya, desde el punto de vista de los blancos, ¿cierto? Boris señaló que en definitiva dejaron los recipientes, ¿cierto?, abiertos durante una nevazón con la finalidad, ¿cierto?, de recolectar nieve fresca. para usarla como blanco. ¿Sí? Correcto. Ya. ¿Y qué resultados tuvieron con eso? Respecto de, digamos, del recipiente calcinado, digamos, por así, ¿no? El recipiente solo, pelado, ¿no? Sin muestra.
Bueno, los resultados de muestra de nieve.
Sí, para que lo escuche la. Ahí le están haciendo señas.
Resultados de muestra de nieve, ¿está escuchando?
No, creo que no, seguramente está.
No existen resultados todavía de muestra de nieve, ya que esta temporada, este invierno que pasó, fue la primera experiencia y bueno, respecto a los microplásticos en distintos ambientes, generalmente se estudian trazas que sean visibles o cercanas, digamos, a microplásticos más que nanoplásticos. Entonces la idea era tratar de aplicar un muestreo que nos permitiera enviar las muestras a donde las pueden analizar para nanoplásticos. Pero la experiencia nos mostró de que habían realmente un montón de etapas en donde podíamos introducir contaminación. Entonces ahora no queremos tampoco hacer ningún procesamiento en nuestros laboratorios, sino que queremos enviar los frascos tal como están al laboratorio del colega de Estados Unidos, que amablemente se ofreció a hacer los análisis, y para, con esta experiencia de esta temporada, determinar si el muestreo es apropiado o qué es lo que tenemos que mejorar. Entonces aún no existen resultados.
Y el resto de las muestras que no fueron recolectadas con nieve fresca, de alguna manera se recolectaron directamente de la nieve superficial del sector del Monte Fento, ¿correcto?
La nieve se trató de que siempre fuera fresca. Lo que es menos fresca son las muestras que, suponte, se muestreó en la mañana y la nevada fue en la noche.
Ya.
Esa, digamos, es la muestra más vieja, pero no se recolectó nieve dura ni de días anteriores, sino que solamente de la última noche.
Ya.
Y en ese caso, cuando no estaba nevando, en el momento del muestreo, entonces se arrastró el frasco por la superficie, por los primeros centímetros, para colectar la nieve superficial, y se empujó con algún utensilio, una cuchara, que también había sido pasado por la mufla.
Perfecto.
Y se tapó y no se intervino.
Gracias, María Angélica. Sí, es que este punto lo pongo yo también a discusión de los colegas de Japón, porque en general, digamos, porque no hay un protocolo aún a esta altura de la vida, después de no sé cuánto, ya llevamos más de 10 años hablando de microplásticos en distintas matrices ambientales, no hay un protocolo único. Lo discutíamos ayer en reunión con los colegas de Japón, que obviamente el doctor Tanaka, digamos, mencionó que efectivamente tenía una dependencia específica del tipo de muestra. Si la muestra tiene mucho contaminante orgánico, si tiene menos, si hay que atacarla incluso con peróxido de hidrógeno, etcétera, etcétera, para justamente, dependiendo cuál sea el fin, el último también del análisis, por supuesto, del tipo de muestra.
Of the analysis, depending on the sample independently. And also in the sampling procedure, there's no unique protocol yet. And there's also a phenomenon that we have identified in our own samples associated to the determination of chemical compounds and particles, which has to do with the fact that snow is a dynamic matrix. Therefore, it accumulates itself. Therefore, it is different. If I took the sample at the moment after a snowfall, when the snow is clean and it's just fallen, then after a month, when it hasn't snowed on that area since the last time it snowed, because during all this time, all the accumulation happened. Plastics, microplastic, chemical compounds, aerosols, and so on. If I will make a determination, and it will tell me that the place is clean. But if I go a month afterwards and take the same sample with the same snow, he will say that the snow is highly polluted. So the question is, the underlying question is, what is the real concentration? The first one or the second one? And there is a dilemma there, because and it's not published yet, it's not discussed yet. The question is hanging in the air. On the other hand, down in Magallanes, we also have the wind factor that makes the snow to be displaced or redeposited, even when it's still snowing. So in samples where you connect the falling snow, but much of that snow is falling into the jar because of relocation, because of the wind. We have those factors. So the idea is take note of all the details for each sampling so as to draw a final conclusion. This is a proof that the complexity of this type of sampling has, environmental sampling and its interpretation. So, any other question? I have a very brief question to Maria Angelica about the station. If you could tell us, I know it's not part of the topic, but some trend in terms of precipitation, if temperature has declined or increased in the area of Punta Arenas. Thank you very much. Yes, it's quite clear that climate change is causing a warming up of the weather because there's a ski resort down there, and this ski resort hasn't been able to open in certain years. This year they opened, but last year they were open for a brief time, and the prior year they couldn't open. So for about 5 years now, the skiing season is not normal. We will be left without snow at some point down the road. So there's still this thing about looking for higher altitude sampling sites where it's colder. And in that case, we have seen that there is a ski resort in Aysén, close to Coyhaique, that's higher, and it could be a very good sampling site, but that means that we need to convey this to another person, to a third party, because we can't travel over there all the time. So maybe we need to start thinking about new sampling sites. The good thing about that place is that the one that we used with Boris is that he has his station where he measures aerosols and other parameters. So it is established already as a scientific station. Thank you very much. Any other final question for our third panelists? Now we move on to Ruben Araya. Aerosols and meteorological observations in Antofagasta.
Pero yo.
La primera pregunta tiene que ver con justamente la transecta que mostraste en una de las publicaciones que hicieron colegas tuyos, ¿cierto? Que lo que me llamó la atención ahí es que tomaron muestras de suelo, no tomaron muestras de relaves o de otro tipo de acopios, digamos, de residuos sólidos que pudieran resuspenderse, ¿no? Si bien es cierto, el suelo, por supuesto, que obviamente tiene...
So the ground, the soil, has a certain suspension capacity, but it's more interesting certainly to take samples from metals that are concentrated, that obviously are mining residues. And why they shows that transects and the sampling. On that study, they installed sediment traps. What I understand is that it's not directly to the soil. Therefore, it is what the wind transports. Something else, the commentation. You talk about sediment traps, but it's no lake sediments. It was sedimented particulate material. So it's on a height, on an altitude. And the other study, they took samples that are on the first sediment millimeters where it's deposited. that's the Koya pond, where they took a sediment witness and they date it, and they make that notation, adaptation, what the sedimentation rate was like. And this, that's the transect that you showed? No. There was one, there was a suspended pole, and the transect latitudinal was the sediment trap. Now the question there is if they had made any correlation, obviously, between mining sites, because that would be the main source, maybe kilometers away where you took the transect, but they could have been fed by deposition or transect, or might have reached a village, or might have had a bigger exposition or exposure. That's how they made a difference or differentiated from the soluble salts and non-soluble salts. And then
también con algunos elementos que podrían ser efectos de la industria minera, pero no estaban los puntos sobre estos pasivos ambientales.
Sobre ningún relave, digamos.
No.
Tampoco al inicio.
No había ninguno. Solamente el que podría estar más cercano a donde están estas pilas, el estudio que tomaron unos polvos suspendidos que existían en las primeras milímetros del sedimento.
Sí,
y los que se transportaban, donde medían los metaloides.
Ajá. Ya. Es interesante porque, como digo, sería súper interesante contactarse con tus colegas en esa área, porque nosotros estamos desarrollando un estudio similar en Atacama, a través de un proyecto FIC, en el cual estamos justamente haciendo una transecta también, más corta, pero partimos de un sitio, digamos, de emisión directa, que sería un relave, y nos vamos yendo hacia, en este caso, hacia Copiapó,
down to Copiapó with the transect, with the monitoring equipment for particulate, sedimented particulate, and with the determination of tracing elements, including what I told you, the determination of mercury. And that might be interesting in Antofagasta, because there's a lot of mining passives left around and distributed until they find another mechanism to reprocess them. Precisely, yes, that's true. It's interesting because I understand that Jorge also had a study in Atacama, but he studied the system in the high Andes.
Bien.
And he has information about it. Any other question?
Yo tengo una.
I have another one.
Bueno, a ver, como introducción yo estuve
As an
hace
introduction,
algún momento en Antofagasta, me
I
llamó
was
mucho la
in
atención la
Antofagasta
expansión
lately,
urbana hacia
and
el
it caught my
centro,
attention,
¿ya?
the urban
Te quería
expansion
preguntar por ese día
to the
del
hills.
invierno del año 91
I wanted
que
to
tú
ask you
tenías tu
about
prueba como
the winter
ingeniero
back in
pudiste ir por
91.
razones obvias.
You couldn't
¿Cuándo
go
pudiera ser
for
un
obvious
nuevo
reasons.
evento y
When
cuánto
could
pudiera
there
ser, asumiendo que hay
be another
construcciones
event
evidentemente de riesgo, supongo,
with
si en el
the
campamento
constructions that are under
informales,
risk,
sin saber también
and
si es que el
also
Estado ha
informal
construido
settlings
vivienda social donde
where
no
the
vive.
state has built
Y si es que hay alguna
social
idea
housing where
de
it
cuánto ha
shouldn't,
crecido desde el año
and how
91
much
el área urbana
the
de
city has grown
Antofagasta.
since 91,
Sí, súper interesante
the urban
la
area.
pregunta porque,
It's a very interesting question.
la data muestra que es interdecadal, o sea, en cualquier momento.
Shows that
El año pasado tuvimos
that anytime something could happen. Last year we had the Nino event, but it was more on the ocean. It didn't affect so much as other Niños, like the one in 91, for example. So how can we have this event or not soon?
El Estado no ha construido vivienda social, tenemos un
So the
déficit.
state hasn't built any social housing. We have a deficit of social housing. But what has to happen is the illegal settling,
Si bien es cierto,
the
se han generado
occupation.
zonas aluvionales,
Even though there are
evidentemente
some floods
las tomas se
happening,
localizan
but
en
insistently
aluviones.
the occupations take place in places with
Alto
flood
precio por
flooding
la
risks.
población.
So there's a very serious problem with housing, high prices, and that forces population to occupy land that they don't belong to. And migrants as well. So there's housing solutions for a growing city, and this hasn't been approached by the state or the authority. Much less now in the election period. But this is a very evident hazard, where they have built new ways, new roads. In Total, for example, another city, we just had a flood, and a new flood prevention road was built. But in fact, a group of geologists has been taking calicatas as witnesses, and you can make a differentiation with the flooding phenomenon, our avalanche, historical. You can rebuild them up down to several hundreds of years with the sediment layers that have been taking place in these
Ok,
processes.
muchas gracias por la
Thank you very much.
Bien, si no hay más preguntas,
Without further questions,
una última.
No, una de Conilla, ¿no? La bahía Mejillones, había mejillones, ¿no? ¿Ah? ¿Tú que eres del área?
Sí, habían unos mejillones grandes antes, pero ahora ya no existen. Ahora, la bahía Mejillones tiene sus particularidades, que tiene una zona mínimo de oxígeno muy somera. Entonces eso provoca que en términos de moluscos exista muy poco, en ciertas zonas en particular. Y esa zona mínima de oxígeno se está moviendo durante el año. Pero eso al mismo tiempo, como tiene muchos metales en los sedimentos, es una complicación, porque en términos de qué sucede cuando un metal está oxidado o cuando un metal pasa de un estado a otro, y eso apunta también a cómo esta zona mínima de oxígeno se está moviendo, si se hace más somera o se hace más profunda, también es importante.
Eso es súper interesante, quizás eso mismo motivó el gigantismo ahí de los moluscos. Cuando hay falta de oxígeno, normalmente los organismos crecen. Así que pasa eso a veces, en la Antártica pasa lo mismo.
Así
Sí, o sea, también gigantismo. Varios de las especies marinas, digamos, que en otras partes son de tamaños normales, en la Antártica, también en zonas que hay baja concentración de oxígeno, aumentan de tamaño. Y también se da el enanismo en otros sectores donde hay mucho oxígeno. Eso es bien interesante eso. Y la otra pregunta respecto a lo mismo, del tema de Mejillón era, respecto a lo que tú dijiste, si tú estás ahí cultivando abalón, a lo mejor hay que medirle los microplásticos a tu abalón.
Bueno, yo lo tengo en tierra, sí, pero sí, es importante. Nosotros yo creo que vamos a tener que hacer una medición de ese tipo, porque una de las cosas del producto que nosotros generamos está orientado a centennial y millennial, y ellos principalmente se sienten atraídos por aquellos productos que generan menos problemas ambientales. Entonces yo creo que los microplásticos sí o sí van a ser una cuestión importante en los próximos años. Una certificación de microplástico. Claro.
Bien, bueno, siendo ya un poco tarde, muchas gracias por el esfuerzo, por la asistencia al día de hoy, así que nos vemos mañana.
Mañana